Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about Leetcode question number 1544. Make the string great. Given a string S of uppercase and lowercase English character, a good string is a string which does not have two adjacent characters S of I and S of I plus 1, where they both cannot be a lowercase and uppercase with the same letter. Okay. To make the string good, you can choose two adjacent characters that make the string bad and remove them. You keep doing this until string become good. Return the string after making it good. The answer is guaranteed to be unique under the given constraints. Notice that an empty string is also good. Okay, let us see the example. See this. This is an example. See here, they have told us to remove all adjacent characters where the adjacent characters are same but they are in lowercase and uppercase characters. If it is lowercase and uppercase or in adjacent position, then remove them. Okay, so this is what the question states. Now see this example. It is LEEEPCODE. Now just observe this carefully, whether there is some lowercase and uppercase characters in the adjacent S. So this is the characters. You may take this or you may take this E and E, whatever, but this is the adjacent characters, right? So remove it. Now what is the output? It is Leetcode. So that's what the output. Fine. Now take these characters A, B, A, C, C. Now what are the adjacent? I can say these two are the adjacent and these two are the adjacent. Okay, fine. Now A is the remaining characters. These two are also satisfying the condition, right? So what is my output? It is empty string, fine. And then yes is already a single character and it is not satisfying that condition, so we cannot remove this yes. So the output is what? Yes, fine. Now we can do like, we go on checking like any alternative characters are like this. If it is so, then remove the characters and do this step until there is no alternating characters like this satisfying the condition. Okay, this is the brute force approach. Okay, but still, can we optimize it? Yes, we can optimize it. But how can we optimize it? I already told you in the previous video in this playlist, like we can use stack data structure here. But why we can use this stack data structure here? Just observe, if I split this string like this too, this B and this B can be compared easily, right? Because it will be the last element and this is the initially current element. So the stack is in format like last in first out, so that the last element will be what? The first element to pop out. Let me go with examples so that it will be more clear. Just see, this is an example. This is stack. Now, first of all, it is what? A. So whether stack contains any element? No. Just put A. And then B. Stack contains A. So B is my current value because B is the current value. So B, and already stack has a at the top. So AB is a current value. Now AB is a substring we want to delete. No. So just place B here. Don't worry, okay? No, B. So B is the current character and already top is what? B. So B and capital B. So this should be removed, right? Like this should not be removed. But alternating a lowercase and uppercase should be removed, right? So this should be removed. So I will pop out it. I will pop out. Clear? Now again A. So now capital A is a current value and already top is what? Small a. So this should be also removed, okay? Just remove it. Now C. So stack is empty. So directly place C. Now again capital C. So capital C. Now it is a lowercase character. Just write it here. CC is also should be removed, right? So remove this C. Now there is, the string is ended, but there is no values in this stack. So you'll return what? An empty string. So this is my output. Yes. So this is my first approach. So what is the time complexity and space complexity? I can say the time complexity is O of n because we are traversing entire string one time, and also we are pushing entire string in this stack, and we are taking one by one characters inside the stack so that we can get O of n. And what is space complexity? It is also O of n because we are using what? Auxiliary stack space. Fine. Now, can we optimize this solution? Okay, the answer is yes. But how can we optimize this solution? We can optimize this solution in a language where there is a mutable of string. Okay, there's a concept called string mutation. Okay, just see here. We can use this in language where we have string. We can change the string, or we can modify the string like C++, Java, or C. But we cannot use in Python, because in Python the strings are immutable. In C++ and Java the strings are mutable. Fine. Let me take an example so that it will be more clear. The same example, A, B, B, A, C, C. So A, B, B, A, C, C. Okay. Come up with me to understand the solution. Don't just take the cut button. Just come up with me so that it will be more clear. So initially I will take f pointer, it is 0. Okay, and also I will take another pointer I, which is 0. Okay, now this is 0 1 2 3 4 5, isn't it? Right. Now just observe carefully. Here is my what? I pointer, and here is my what? F pointer. Clear. Now we are going to check whether I is some character which is lowercase or uppercase, and f minus 1 is also a character which is alternating to this I. It means just see here, you want to check whether I is lowercase and f minus 1 is uppercase, and they both are same, or else I is uppercase and f minus 1 is lowercase, but they two are same. This is the condition we want to check. Okay, first we are going to check f is already at 0, so it don't have any previous element, so just update it. Now f is 1 and I is also 1, right? Again we are checking whether what is the f minus 1. F minus 1 is a, I is b. So don't do anything, just move here, and just move this I pointer here. Now what is my f minus 1? F minus 1 is b. F minus 1 is what? B. And what is my I is b. So this is a string we want to remove, right? So this is a string we want to remove. Instead of removing, we can modify this b with some other character that comes this side, right? Like I want to say you that just shift this f here, so that this a or this c may be occupied in this position. Okay, so shift this f here and shift this I here. Okay, now can you understand this? Now fine. Now what is my f? F is what? 1 currently. Yes, 1 currently. I forgot to update this to 2 when I moved here. Again it will be 1. And what is I? I is 3 now. Okay, now again do the same stuff. Whether f minus 1 is what? A. F minus 1 is a, and what is current I? It is also a, capital A. So this is a substring I want to remove, right? So if I want to remove, just move f towards minus 1. Fine. And also my I goes to 4. Just take this I and place here. Fine, got it. Now again we are going to check whether f minus 1, but f is 0, then how come it's okay? So update the c here and move this f here. Now do you understand why we are updating this ith element at f minus 1? Sorry, f. Okay, now just observe what is now what is the f minus 1 element. This f is 1, right? What is the f minus 1 element? It is c. So put c. And what is I? I is more here, right? Yes. What is I? It is capital C, right? So this is my substring I want to remove. So I will shift this f where? Here, and make this 1 as 0 and make this as 6. Now loops get terminated, and where my f points? My f points at 0 in this. So what is the length of the substring? It is 0. Sorry, what is the length of the string? It is 0 after removing the all characters that satisfy our condition. Okay, so this is the approach number 2. So what is the time complexity? I can say time complexity is O of n. So what is space complexity? I can say that space complexity is O of 1. Fine. So this is a quite optimal approach, right? Yes. Let us see the code so that it will be more clear. Don't worry. If you don't know till now, it will be clear when we are seeing this code. Just see here. Stack is equal to a empty list, and then for I in S, if stack and if stack is not empty, and also order of stack minus 1 is equal to order of I minus 32. It means if the ASCII value of top element is equal to the ASCII value of the current element minus 32. It means this is what? This is the lowercase and this is the uppercase. We are checking whether the uppercase and lowercase and vice versa. Okay, if any one of this is true, then what should we do? We should what? Pop that element from the stack. Very important note, put this bracket. This bracket. If you don't put this bracket, you will take stack and this condition at first. Okay, this is a major mistake everyone do. Okay, then else we want to append that current element into the stack. Then we will return by using the join function. If you don't know how to do this join function, don't worry, just take a result variable empty string, and for I in just traverse in stack. Traversing in stack is in Python is so simple, and just concatenate each and every element inside the stack and just return the result. Let me submit it. Yes, it is submitted successfully. Now let us see the optimal approach. See here. So this is the optimal approach. First of all, I am just declaring I and f is equal to 0. Then for I is equal to 0, then I is less than s dot size of then I plus plus, just traversing to the entire string. Now f is greater than 0. It means we cannot find the f minus 1 if f is equal to 0. It means f of minus 1. How come f of minus 1 present in that array? So that's why I'm checking whether f is greater than 0. Now s of I is equal to s of f minus 1 minus 32. It means that same condition I have mentioned in Python, right? Like s of I. It means now current element is equal to the f of f minus 1. It means the 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 f minus 1 the element minus 32 means it represent the uppercase. If this is also uppercase and minusing 32 gives uppercase for f, then they both are like s of I is uppercase and s of f minus 1 is lowercase, but still they both are same. That means lowercase a or uppercase a, and then lowercase b and uppercase b, like that. Okay, or else we can get a vice versa. If that's so, we want to what? To f minus minus. Why? We want to go we want to decrement that by 1. Then we will update the rest of the right value here so that it will be replaced, it will be modified. That way I have mentioned, if you can mutate the string, you can use this method. Okay, else s of f is equal to s of I. Okay, now f plus plus, it means we are replacing the current value. It is a pure two-pointer approach. Okay? Now string result, then we are just concatenating each and every characters inside the result, then returning the result. Let me submit it. Yes, it is submitted successfully. You should know this approach. Okay, and in this playlist, next question is also this type of approach. Okay, we will use the stack approach, and also we can use this string mutable approach. Fine, thank you.